Hi, my name is Loren Kristick. I'm an engineering and mathematics educator at Energy Institute High School in Houston, Texas. I worked with Beyond Benign to pilot their Lemelson MIT JV Invent team's green chemistry guide in my own classroom. You're about to hear from Ben Barnes, who's one of my students. He actually went through the guide with me and he's going to talk about his experience. What we sought to do in this project was connect the chem attitudes and invention education frameworks in a way that made sense to students. So we were looking for gains in the areas of interest in green chemistry, self-efficacy, and we were really looking to push the real-world content connection for students. Here's Ben with his experience.
Hey guys. So I'd always thought of chemistry as a not very useful or applicable subject when it came to environmental sustainability. I didn't assume it could be nearly as important as the construction of a hydroelectric dam, for instance, or maybe a wind turbine or some solar panels, the more mechanical mainstream environmental engineering innovations, as they say. However, I came to the realization, in part through Beyond Benign and Lemelson MIT's Green Chemistry Guide, that chemistry actually has some seriously significant applications with respect to building environmentally conscious societies, specifically in the avenue of bioplastics. Now, bioplastics are basically just polymers made from renewable biomass sources, so they're far less destructive to the environment than traditional, disposable plastics that we see today. And since material efficiency is a great way to increase sustainability, it was really interesting how much we were able to learn about this subset of materials that we call bioplastics throughout the 8 or so lessons of the Green Chemistry Guide. Now, the term bioplastic wasn't a new one to me, but I had next to no experience with the material composition of bioplastics or its various applications. But throughout the course of this project, we were able to learn how bioplastics are made, learn how they're applied, and actually in our 7th meeting, we were able to make a bioplastic prototype, like a mold almost, from scratch. And that honestly gave me a lot of hope about what individual people can do to combat the dire plastic crisis of today. And actually combining this knowledge with the knowledge I gained at school about 3D printing, it would be relatively straightforward to 3D print molds for bioplastic solutions that we create to make practical bio-friendly products like door stoppers, cup holders, or even phone cases. And in order to combat the use of these ordinary plastics and the lack of use of materials like bioplastics, some friends and I are actually applying for the Invention grant through Lemelson MIT with the goal of engineering a straightforward method of recycling these ordinary plastic products using current 3D printing technologies. So yeah, that was the 2-minute version of everything I learned and was able to apply through the Green Chemistry and Invention Connections project. Big thanks to everyone who made this possible. My name is Ben Barnes. I'm a senior at Energy Institute High School. Stay safe. Thanks for watching. Take care.